was. I'll start by saying, man, it feels good to be in the blue team room.
Woo!
I went and watched the first talk in the red team room to support a good friend colleague of mine. While the talk was great, the room was horrible. The lights were out. Everybody was wearing hoodies. It smelled bad. It was my thing, so I'm glad to be able to sign people here. That gave me a great introduction. I won't spend too much on that. But I spent most of my previous career in the Department of Defense building and leading various forms of security operations centers, basically catching bad guys. I do that now for fire. I spend most of my time trying to figure out ways to build a better mousetrap and investigate what gets caught in a mousetrap, which is not always the prettiest thing you gotta do. Aside from that, I am barbecue pitmaster. I'm from the South, we're in the South, and my gosh, if you're going to be in the South, I would love a picture of ribs in your presentation.
Yeah.
So there we go. I've read a couple books that are interested in hack analysis or network security monitors, and that'd be something you want to check out. So this presentation is a little bit different, and I'm not going to talk about ones and zeros so much. I'm going to talk a little bit more about matters of the mind. So I am currently in the process of, I'm interested enough in stuff, I'm pursuing a PhD in cognitive psychology to apply it to the investigative process and how we catch bad guys. But at the end of the day, I'm still not a psychologist, so your knowledge may vary, and that's worth disappointing. So I try to put a sentence with every one of my presentations that says ultimately what I hope people can get out of it. And the real thing to this presentation is the concept of metacognition, how it applies to the investigative process, and the benefits we can really derive from that. Just a quick show of hands, I know so last year I talked about cognitive bias. Did anybody see that talk either there or online? So several of you, of course all my coworkers, so thanks, even if you're lying. So we're going to talk about metacognition. And metacognition is a big fancy psychology definition, but ultimately it's thinking about thinking. It's examining our thought processes and determining what's happening between left ear and right ear that helps us solve highly complex problems. Right? And that's not a challenge that's unique to our field. It's something every field that involves some level of critical thinking has to deal with. We're actually just a little bit behind the curve in it because our field is so new. The interesting thing is that research out there shows that there's a value to understanding and applying metacognition in what you're doing. Right? It's two components. So one is knowledge of cognition, so that's ultimately understanding how you think, how you approach complex problems. And the other part is regulation of cognition. So it's taking what you understand and applying it to what you do. Other fields, again, are very good at this. Medicine is one of them. My wife is a medical doctor, and part of her training, we talk about this, really very little of her training, prospectively speaking, is focused on drugs and medicine and diseases and ailments. A lot of it's how to think clinically, how to approach things, how to do diagnosis from a cognitive sense. Deductive analysis and things like that. So other fields do this too, and we need to start doing more of it. That's kind of my thesis statement on this, is we need to do more of it, and if we do, we'll be better at, again, catching bad guys. So we're going to talk about metacognition and the concept and the kind of frames the investigation. We boil down to what all of us do. Doug gave a good example of it yesterday when we talked about good versus evil. And really the construct we use as blue teamers to frame good and evil and find bad guys over the investigation. Whether you're a triage analyst or a malware analyst or a reverse engineer, ultimately you're doing some type of investigation, right? How many people in here do some type of investigation as part of their daily job? Most, very nearly everybody, right? Like how many analysts do we have here as far as you get alerts and you investigate them and you do stuff with that? Several of you. Great. So we're going to phrase things in terms of an investigation. So, what happened? Is there a bad guy? If so, what did you do? By the way, does anybody know, there's a lot of things I guess all bad guys have in common, but there's one big thing that I think applies to any bad guy no matter what. What makes them a bad guy? Anybody have any thoughts?
The hoodie.
The hoodie? That's it. No, that's not the answer. Motivations? Yeah, I think so. So the big thing is, the way I phrase this is ultimately all bad guys want to steal something from you. Right? And we think about that in different ways, right? Stealing something can be something tangible, like intellectual property, actual physical item. It can be something a little more nebulous, like your time, your resources, your reputation for that matter, especially for big corporations that think reputation matters, and that damage that hurts a lot of people. So attackers ultimately want to steal something from you. So that's a little bit of an aside. So we're talking about perception and reality. I showed the same slide last year, and the big thing to understand is we have perception over here, we have reality over here. And there's a gap between those. So we have to acknowledge those are two separate things. Perception is how we see and interpret the world, and reality is how it exists. Now there's a whole existential discussion about whether reality is real and all that, and that's outside of it. But ultimately, you have perception to reality, and investigation in most cases is simply getting from perception to reality and hoping the reality is correct. Right? Now, I'm drawing perception to reality here as a straight line, but in most cases, it's actually a little bit more like this. You have multiple paths you can take, various options within those paths, and when you get to reality, a lot of times you really have no way to validate whether you're there. But when you are there, you hope you're taking the right path. Now, the trick is how we navigate this kind of web of perception of reality is based on two main things. One is our mindset, where we see the world, and the other are our biases. So if you saw me talk last year, I talked pretty much exclusively about biases. That's out there online if you want to look at that. Do so, I'm not going to delve into that too much here. Biases are part of that, but the other is really focused on mindsets. Now, mindset as a person is shaped by really everything. It's shaped by where you're from, your parents, your family, your friends, your experiences, both good and bad. Mindsets are not a good thing, they're not a bad thing, they're just a thing. They can affect us both positively and negatively. So that's what, when we see the world, that's what we see the world through our mindsets. The interesting thing that the research shows us is that mindsets are very quick to form and very resistant to change. Right? Humans are inherently judgmental. We don't hear that, we are. We judge people, we judge situations, it's just what it is. Not a good thing, but that's where we are. So the important thing to understand this is the concept of what I just will call initial blur. So when we're presented with a really complex cognitive challenge, we have some level of blur, right? And that's when we talk about our perception, it's blurred. We don't know if it's reality. We have to do some critical thinking and pull in data sources. We have to get to that reality. Now, the thing with initial blur is, and what research in other areas shows us, is that the higher the initial degree of blur, the harder it is for us to get to a more accurate perception of reality. Right? So if things are just a little nebulous, you kind of know what's going on, but not really, versus you really have no idea and just all the data's out there, there's a big difference. It's not just the time it takes to go out and get the data, it's the ability for our mind to put it together. That's kind of a big deal, especially in terms of like alert investigation, right? If you have an alert that comes to you and you have all the data you need to investigate right there, you're diminishing that initial alert. And that's very helpful. Versus if you have to go out and go to multiple data sources and get all that data, you have to go to the host, and you have to go to the network sensor, and you have to go to whatever else and pull that back, and you don't necessarily have that complete picture. At first, it's not really very diminished. Now, that's something we can't really hopefully do a lot about, but there are some things we can do. A couple of examples. One obviously is providing relevant information up front when you can. That's pretty helpful. The other thing is moving towards the concept of what I call realistic time learning. Everybody talks about real-time learning. I'm sure somebody knows the stat. I'm sure that part of the room definitely knows the stat. What is the average time from breach to detection?
200 days.
Yeah, it's a little over 200 days, right? So if the average time from breach to detection is 200 days, is it reasonable to all of a sudden say, we want to catch every breach at real time, like the second it happens? And that's setting the bar maybe a little high? I think so. And ultimately, the fact of the matter is, when an attacker gets in, when he first breaches the network, he's not done. And it really hasn't accomplished his mission. The goal isn't to stop the attacker from getting in at this point, in my opinion. It is to stop the attacker from accomplishing the mission, from stealing the data. That's hard. I make fun of the red team guys, but their job is just as hard as ours. And I don't really like to hear that, but it's very difficult once you get in. That's a lot of times when this challenge starts. That's when you have to move around, get past other controls, find the data that you need to find. I try to find data on my own network, let alone someone else's. So that's a problem sometimes we can all relate to. So realistic time of learning is using processes, designing processes we use to analyze data in a manner that is delivered to us more completely, as opposed to just giving us an IDS alert and nothing else. Right? I'm perfectly fine with an alert coming in 4 hours after the initial detection, even maybe 4 days after the initial detection. If it gives me a whole lot more information, it's a lot more enriched, it's a lot more actionable, and has a lot more information that I can use to go forth and investigate further. That's what I talk about when I talk about realistic time learning. That's something we're not really doing a lot as an industry right now. Everybody wants real time, and I just don't think real time is realistic. The other thing is formalization of the triage function. So when I say that, I talk about the process of getting an alert, putting together what little information you need to make a very preliminary decision on whether it's a quick false positive or needs more investigation. So I believe you get more out of your analyst in terms of cognitive workflow when you break that off as its own function. So what I'm talking about here in big organizations is 2 levels of analysis. So your alerts come in, your triage analysis gets the first alert, gathers information, makes a recommendation, passes it on to someone else. And there's one reason beyond initial blur why that makes sense. One is bias, as we talked about before. Analysts form biases, and that may shape the investigation, so we hand that off to another analyst. They can then usually apply their different biases, and then you eliminate some of the biases at that point, so that's very helpful. Obviously, that's not very realistic with small organizations. Partner analysis is a good way to do that there. One analyst who gets the alert, does the initial information gathering, puts it together, makes a recommendation, passes it to the next analyst. And then that's when the second part, you can flip it back and forth between days. But I think formalization of the triage function is incredibly important for that area. Another thing I want to talk about is inattentional blindness. So attention is really neat because it basically allows us to focus on things. Many of you are focused on me. Some of you are focused on your phones. That's not too. But many of you are focused on me. And it's our attention span that lets us do that. Now, I think we all know that attention is somewhat of a finite resource. Many of you are listening to me now, may not be listening to me in 10 minutes. I get it, that's fine. We just had to ask, very too much. But attention is an interesting thing. So there's overt attention and covert attention. Overt attention is when you are actually looking at something and giving it visual attention. So it's looking at this person on the front row, there's an overt attention. Sorry for calling you out. Covert attention is when somebody has your attention that's off to the side. You're not necessarily looking at it. So if there was a sound going on behind me, I was actually looking at it, that would be covert attention. It would be fighting for my attention resources. Again, it's a limited resource, there's only so much of it. When we talk about analysts, we have to be very careful about where we apply our attention. Because there's a lot of things right in front of us. And our tools don't always do the best job. So for instance, I'm glad the screen is big because the text is small, but this is a TCP output. And there may be a couple things people find anomalous. Does anybody find anything? And if you read my blog, you've seen this since it's spoiled. Does anybody see anything maybe a little more anomalous than something else? Data on a SIM packet. Packet group? Yeah. Data on a SIM packet. That's perfectly fine, but it's a little annoying per spec. It's RC, perfectly fine. But as far as from an analysis perspective, that's something maybe we're not used to seeing. And the thing is, most of us don't see it. I know if I saw this packet capture, I probably wouldn't notice it the first thing I made it actually, so it's not know about it. But otherwise, if you're not kind of attuned to looking for those things, if your attention isn't, you don't have the experience level to know where to look at certain things like that, or something just falls outside of a normal attentional boundary, where you might focus your gaze, you're not going to notice it. And that's really probably the biggest cognitive challenge of any analyst is attention to detail in the right areas. Not just attention to detail, you have that experience back and put it in the right areas. And that's very hard to do. We'll talk about training challenges here in a minute. But ultimately what I'm saying is it's very dangerous things right in front of us because of inattentional blindness, which defined is ultimately saying looking directly at something but missing something that you are giving your over attention to. So the interesting thing, I guess, is this is TCP. It's an example of a tool, which is a very useful tool. I love it. I use it almost every day. But it doesn't really do a lot for us in terms of directing our attention. Right? And that's why people like tools like Wireshark. Right? First of all, it's graphical and that's a little easier. But it also has a lot of different visual cues here. We see that these packets are linked by this little visual cue and color coding going on. Various section headings, visions of different types of data. All very useful visual cues that help serve to direct our attention. And I show this as a kind of a message to the folks that are responsible for configuring and setting up an analysis environment, because it's very useful to build in these visual cues so that you can, especially if the analysts are inexperienced, direct their gaze in a certain location and help focus that attention. So diminishing inattentional blindness, again, experienced analysts are usually less susceptible. The other thing that's very important is mastery in your environment. If anybody cooks a lot, you've ever heard of mise en place, everything in place. If you ever watch a professional chef work, when they grab things, they often aren't even looking at them because they master their environment. They know that their cutting board's here, and their ingredients are here, and their knife is here. They know where it's all at. Just like that, as analysts, we need to know basically where our data lives, what tools we use to access it, and what the limitations of those are. At any given time, you should have a pretty good understanding of, I have a question related to an investigation, how do I go out and get the answer? The less time you spend figuring out how to get the answer, the more time you can get in and analyze the data, the better job you're probably doing. Another unique thing, and one of the areas I'm focusing on right now, is gaze studies, where you have a device that sits on the computer, it fixates on your pupil, and tracks where you look on the screen and compares certain data. So we throw data, we can, they use this in other areas of psychology. It's basically a way to look at different data points, because ultimately our eyes move faster than our brain interprets what we're seeing. So oftentimes we're looking at things, analyzing things in order and in fashion, or focusing on things in a way we actually don't know what we're doing. So gaze tracking, overlaying things like these heat maps here and directional arrows to show which way our gaze moves, does some pretty neat things in terms of data analysis. So my hope is maybe this time next year I'll have some cool things to show you in that regard. So intuition and memory. SOCs are interesting. In Kansas State University did a study a couple years ago now, talking about the ethnography of SOCs, so kind of the culture of the Security Operations Center. And the biggest finding they had that just stuck out to me was kind of the top of it. Investigative knowledge is tacit. Tacit, what does that mean? Well, it means you can't really often write it down and tell people how to do it. So if you go up to someone who's an expert analyst and say, hey, why are you so good at finding evil? They often can't tell you. Right? They might cite some tools or something like that. They can tell you the thought process they go through. And that's a bit of a problem. Other fields face it, but in medicine, if you ask a doctor why they're good, they'll often say, well, it's because I use this process or this process or this process. And they're usually a little more metacognitively aware than we are in our field sometimes. The problem being that with senior analysts can't explain why they're good at what they do, junior analysts can't really learn. And that is a problem. So, all that's to say, summed up, is analysts rely on intuition. Intuition is a little bit of an interesting thing, because up until somewhat recently, it wasn't really accepted as real. Most psychologists, even the Sigmund Freud, who most people, it's kind of a household name in terms of psychology, have this quote here that intuition is basically an illusion, and you shouldn't really expect anything from it. So that's interesting, but modern technology has told us a little bit more. They have a great device now called an fMRI machine, and you may have had an fMRI scan for some reason. It basically allows you to perform experiments and measure the output of certain parts of the brain. You see fMRI scan results at the bottom left here. Yeah. And what they found through a series of experiments, and I won't go into the details, but you can see there's an interesting TED Talk, and I can provide the research if anybody wants to see it. But basically, by examining professional versus amateur chess players and seeing how they interpret movement and how they make their decisions, they identified an area in the brain called precuneus. And it's, you see this map there, it's right about here, right about on the top of my bald spot. That's the precuneus. And they think that intuition is basically spawned from there. So what they're saying is they think there's a biological basis for intuition. It's actually a real thing. This really changed how the psychology world looked at intuition as a construct. It wants a whole lot of more interesting experimentation, which is interesting. So I don't have a lot of time, but I want to step aside and talk about memory for just a second. Memory, very simply, there's a lot of models for it, a lot of ways to explain it. The most common is this right here. Sensory, short-term, long-term. You think of sensory is if you're looking at me, close your eyes, and if you see the screen on your eyes for just a second, that short second is kind of sensory memory. Short-term memory is called working memory a lot of the times, and it is ultimately the memory model we use when we're actually solving problems, which are our near-term memory. You have to repeat something frequently to keep it kind of fresh on your mind. You're using short-term memory. Long-term memory is obviously where our long-term memories are stored. Think of short-term memory like RAM, long-term memory like this. Reason. So there's a lot of memories with working, or a lot of models with working memory too. And one of the most common is Bagley's model, which consists of these four components right here. And the one that's really interesting is the Visuo-Spatial Sketchpad. And it's what we use to visually manipulate objects. So you see I have a picture of a cube on the screen right now, and the green square is on top. Now if you put that in your mind, you can imagine the green square rotating, so it's facing you. You're using your visual memory, your Visuo-Spatial Sketchpad as part of working memory to manipulate that. Right? And the interesting thing about the Visuo-Spatial Sketchpad is that it also will be mapped to the precuneus. Right? So the general hypothesis right now is that people believe that intuition is strongly related to our ability to visually picture solving problems. And that changes a lot of things. Right? Like we know that if we have a lot of complex data, like visuals help us parse it. But even for like very simple problems, the ability to picture things could be one of the keys to greatly increasing the human cognition and perception for reality gap, or decreasing the gap, and increasing our ability to solve problems. Right, so that's very interesting. And if you think about a lot of other fields, it kind of applies too, right? You talk to expert chess players, they'll say they can see the board, they can see 5 or 6 steps ahead. Talk to stockbrokers, they can see the patterns that go on. Even musicians can say, virtuoso expert musicians are often quoted saying they can see the music beyond just hearing it, right? And that could very easily apply to the world of security investigation as well. So how do we apply that? Well, there's a lot more research to be done there. Very simply, the first thing is draw a picture because your brain's probably trying to do that anyway. Subconsciously, right? There's a lot of things going on in our heads that we can't really, we don't really know are happening, but the theory is that maybe is happening anyway, so you draw a picture to help yourself out. The other thing is to visualize that appropriately. And I'll be the first one to say I hate stupid visualizations. Like, you always have to have the guy who's like, I'm going to take every floor in the network and draw a big graph for it, and like, here's a bunch of cluster dots. He knows what they mean. Everybody does it once. I've been there. We're all going to call it, right? So, but that's an interesting way. I hate bad visualizations. Some of them are very useful, right? Incident timelines. I think we all love incident timelines. We can visualize things occurring over time. That's usually a win. Another thing is link graphs. The ability to visualize relationships, and that's pretty clutch. So we can visualize relationships of a lot of different things, right? We can visualize relationships of breakfast items. We're in the South, so they're course server grits. But you can eat grits, then you know what breakfast is. So you can think of breakfast in terms of visual relationships, nouns and verbs. You can do the same thing with breaches, right? So we can very see clearly kind of where the center of the breach is here, and we can see how things relate to it. When we can see how things relate to each other, we can map those to schemas in our minds, because memory is mostly thought to be organized in terms of schemas. And if we can do that, we can remember things quite a bit better and use working memory more efficiently. Interesting thing about working memory too, it's also a limited resource. Just like attention, only so many things can be held into working memory. Some of you may have heard the term magic number 7, and that's to say that generally most humans can remember 7 kind of low fidelity items in their mind at any given point in time, plus or minus 2. So the range is kind of 5 to 9. And the complexity of the items matters. So obviously I have a couple of relevant examples here. So if I, as an analyst, am trying to solve a very complex problem and piece together a lot of different pieces of the puzzle, and I have to remember this, then that's going to take up part of my working memory and really decrease my effectiveness versus remembering something like this. Now, granted, we all know there are follies to just trying to associate with it as a file name because it can change and so on. But it's important to understand these capacity limitations. So a couple quick ways to diminish this. This is another area where more research is going to be required. One is source monitoring. One of the number one reasons people make memory errors is because they forget where they learned something. That may be a person. You think of a conference talk you had a couple of years ago, and you can't remember who gave it, and that's a source monitoring error. Same with information. I don't remember if I got this information from SIM or got it from packets or post-data or memory. I don't know. The other thing is chunking. And chunking is an area, especially in this area where there's not a lot of research, but basically the ability to group things together similarly. And this is the technique people use to remember, pi to 100 digits. Chunking like numbers together and dissecting them somehow. The ability to chunk information in our tools and how we do analysis in that way. The last thing, very quickly, is mapping things to schemas. I mentioned this and talked about breakfast. If I ask you to remember these 5 items a day from now, you're probably going to forget them. If I ask you to remember these 5, you might be more likely to relate them to the schema in your mind, which is breakfast. So mapping things to schemas is a really key step to that relational type analysis. So that's pretty much it. The big thing, I said you have to be kind of knowledgeable about your cognition and as part of that cognition, and you have to apply it. This talk was obviously a little bit more about gaining knowledge of it, because some of the research to apply it really hasn't been done yet. So my hope is people can take this, they'll get interested in it, and maybe we can get some more collective industry understanding of how we think, and think about thinking, do more research, and do more cool things. I'm certainly going to try to do some of that myself. Any questions?
Yeah, I have one. So we kind of talked about like this memory working set. And we kind of see that with like jargon and words. Do you think that that's something that would be good for an incident response team to kind of come up with here's the shortened versions of all these things and we all agree on it, so it's easier to
Yeah, sure. I mean, it's all about, the question is kind of the common nomenclature really amongst your team. And that's certainly good. I mean, when you consider that the working memory is a finite resource, the more time you have to spend translating a word you don't know to a concept you do know is time you can spend doing other things that are more important.
Besides adjusting how you look at your Wireshark console, how are you applying this in your day job? What other ways would you have to do it?
So I think, so how do you apply this type of thing in your day job? And I think there are kind of two sides. One is for the tool developer side. We kind of all understand that there's a lot more work that goes into that. From an individual analyst, what can I do to take this knowledge, make it more applicable to me as an analyst? I think the big thing is guarding, is kind of putting a shield up in front of your working memory. Like we all want more data and more data. But at the end of the day, we do the best analysis when we get just the minimal amount of data that's needed. Right? So it's not going out to a sensor and getting a gig of keycap and getting rid of the things you don't need and whittling it away. It's going out, it's figuring out what we think we need, maybe starting with flow data, figuring out what flows we're interested in, and then going to the PCAP and then just getting what we need. So it's guarding your working memory, keeping a very finite focus on what you need and trying to make sure it's available very, very quickly and not really cause the maximum.
So when you're actually trying to bring up analysts, when you have that new analyst, and you mentioned that teaching them is very difficult, I can agree with that completely. Are there any particular approaches you found that work better to get that kind of knowledge transfer working with them?
So are there any approaches for teaching new analysts using kind of some of these methods of how to be analysts that are beyond the typical watch and learn model? I think there are. I'm still early enough in my research. I'm not going to say I have all the answers on this because I don't yet. I'm hoping that we get there. But I don't have anything concrete to apply yet. I've got some general ideas, but I don't want to put them out there until they're based on my test.
Hey, I find it interesting you said keep 7 digits, magic 7. But I've heard that you can see 30 distinct things in your view at a time. And then to go with that, I always heard that Einstein and Hawking they'll convert problems into geometric problems and then work those out between their heads. So maybe there's a correlation between the two.
Absolutely, and I think what you're talking right there is the schema thing, right? Like those guys, they have schemas for these computations, and they can take all these things they couldn't remember otherwise, fits into the schema that is a mathematical computation, and understand that very well, then that's their cognitive shortcut to remembering all of those things for sure.
Okay, great talk, Chris. We've got a couple giveaways.